Welcome. My name is Jonathan Asher. I am the architect behind the CATIA roles available for the construction, cities, and territories industry on the 3D Experience platform. The motto of CATIA is to shape the world we live in, and we serve a number of different industries. A few years ago, we transitioned from a look or a focus uniquely on architecture, engineering, and construction, and expanded that larger to construction, cities, and territories because the reach of CATIA is much greater than just in either design or engineering or building, manufacturing. It's also constructing at the scale of infrastructural works, whether it's bridges and roads and railways, and design of large-scale networks. The principles for our CATIA construction portfolio is to be smart, modular, generative, and seamless. Seamless being continuous LOD from concept to detailed, including fabrication and assembly information all within that 3D mockup. Generative, we've covered on generative. It is a powerful generative parametric modeling machine. Modular, it's very parametric. You can create these intelligent adaptive templates that embed knowledge and know-how. And smart, in a sense where you can define your requirements and execute a systems-based approach to this multidisciplinary processes. The thing to remember though is CATIA is a part of the 3D Experience platform. This platform has one data model, one collaboration environment, and all of the brands that develop products are integrated into this platform. They share a data model, and they're interwoven so that you can start a model in CATIA and you can open it up in Simulia for simulation. You can bring it into Delmia for manufacturing, and then you can manage the project management with Innovia. So it's a real inclusive platform that brings together all of our applications. Another example of where that's being put to use. So we've got the parametric components, parametric units. We've developed a smart space planning algorithm for turnkey hospitals with a partner that's located in China. And this was developed early last year in response to the COVID crisis in Wuhan, and where they needed to build in rapid time hospital facilities to support the rising cases of COVID. We partnered with a company called Aiden on this project, which is Akilicare, to create this space planning algorithm and then take the units, the hospital units, apply them to the space planning algorithm and link then the conceptual or the space planning module that we see, or model that you see here, with the more detailed models. Here's a look at the module then that was the standard module issued by the Chinese construction authorities. We insert that module into the space planning model, and you see now it maintains that parametric association. So as we update the 3D model, that all of the layout of those units updates accordingly. These units, we instantiated them at a relatively low level of detail because later on then, once they've been instantiated, we can add these higher level of detail components. So that was a generative framed wall that you saw as an X-generative design model that's driving the geometry of the framing and everything like that. And it's been embedded in what we call an object type. That object type is inserted into the 3D model. And then you have access to those parameters. In this case, we inserted the model using incorrect alignment parameters. So we're going to adjust those parameters and see how it is propagated throughout the model. Included in each one of those templates that we just instantiated are the manufacturing information, the fabrication information. So that information can be extracted for the machines for fabrication, but it can also be extracted, and the drawing, the assembly drawing that needs to go out to the shop, can also be extracted. This is another example of a project that we've worked on recently with a large property developer in India. And the challenge for them is they receive opportunities to purchase land on a regular basis And when the opportunity arises, they need to find an architect and ask an architect to help develop a scheme to validate or to decide whether that project is financially feasible or not. And this takes time, and oftentimes it takes too much time, and they don't get enough and they don't receive enough options, design options or information. So it's challenging them to make an informed decision. So what we've done with them is we've developed this X generative design model to help them evaluate uh, potential sites to purchase to develop, uniquely for residential properties. They have a set number of residential units that they prefer to build, and so this generative algorithm that's takes a site as an input, a number of preferences or site properties that they would like to develop, that they'd like to optimize for, and then the algorithm is going to lay out the units in an optimal way given the site configurations based on core placements and orientations. The algorithm produces then the 3D model, it generates the structural model, and then this is the skeleton that can be used as a support or as the context within which you instantiate your more detailed units. This again, this model is going to output a number of KPIs, and one of those things that's exciting then is you take those KPIs into what we call the optimizer. So the optimizer is going to ask which parameters you would like to iterate and which parameters then you would like to evaluate. And you run and you set a number of iterations you'd like to generate within a certain range, and it will output then the values that you'd like to record into a table. You can pull it into Excel and you can crunch some numbers and find the variations that you'd like to classify or look at closer, like we see here. So this is a way to take it one step further. You create your generative model, you integrate it into a design of experiments engine to produce variations and learn as you design and refine the design with real big data. This last example is a look at how X generative design has been used in a hackathon that we organized in 2019. We've worked with a number of great architects in the past developing X generative design so that it meets the needs of our users. And one of the ways that we work with architects is we organize hackathons or events to get people using the software. We did it back before the application was even released as a beta product. That was back in 2017. And this last hackathon from 2019 was exciting because it was looking at how we can integrate X generative design into an urban and use it as an urban design tool within the context of 3D Experience City, our big data GIS-like software application that's also available on the web. And so here's a look at 3D Experience City. This team that was led by a group from Shop Architects developed this generative city block. And this city block is able to transition from the old context of the Parco Sempione to the more modern area of the City Life neighborhood there. So as the city block that's being developed transitions from the old, where you have one building typology of rigid small buildings butted up right up next to each other, as it gets to the City Life area, the buildings get rounder, there's more space between them, they get taller, and they become more modern. So this generative system also takes data in from the city context to help balance the amount of residential versus commercial versus mixed-use spaces that go into each one of the city blocks, and that's the color that you see represented here. What is the building program? Finally, then, this can scale, and the goal in all of this is to build the 3D Experience Twin, which is an extension of the virtual twin because it includes relational data as well. This is an extreme example, but it shows the power of the 3D in a database because the 3D Experience platform is on the cloud. It's all of the objects are on a database, and they have links between objects. And so what we saw there is we saw a relational link between the switch, the power switch, and the power outlet. And by navigating through the relational link, we highlighted the geometric link through the conduit. And each one of these features is a PLM object. It's an object that lives in the database and has all of its information attached to it. The specification of the product, the life cycle of the product. In this case, we see the spec sheet, and it's all there attached to the 3D object. And this is again an extreme case, but a beautiful case of the scalability of CATIA and the 3D Experience platform. And what is that used for? It's used to build that 3D Experience twin. And again, this is a final video about the Brock Commons, showing how on a project where the 3D Experience platform has been deployed as an engineering and construction tool, this project was able to save $3.5 million on a $50 million project, and over 6 months in installation time, because everything had been, all of the CLT panels had been precision cut straight from the model. All of the assembly offsite and onsite had been simulated and optimized, and it allowed all of the trades that were working on site to fully invest into the model, to fully put all of their faith into the model, and really maximize the return on investment for working things out in the 3D model before, in that virtual universe, before trying to work things out on site. And so with that, I thank you for your time. I hope this has been an entertaining and insightful lecture that was showing some of the recent things we've been doing with XGenerative Design and CATIA as a whole, building parametric generative models for design for manufacturing and assembly processes that I am thoroughly convinced will revolutionize the construction industry. It's really only a matter of time. The industry as a whole is really struggling right now to maximize margins and maximize gains and really transform itself as technology is disrupting all of the other industries around it. So thank you for your time. Have a great day.